Good morning, students. Is it audible to you? So we will wait few minutes. So students are joining. So we'll wait 2-3 minutes. We'll wait. Till that time, do you have any doubts? Girls and boys, you can send it to me. We'll discuss. Girls, is it audible to you? Clear? My voice is clear? Girls, any doubts are there from your already you practice the question? I told you to practice some question. Still have any doubts from your module? You can send it to me in a group. We will discuss now. We will wait at 2-3 minutes. So students are joining. After that, we'll start. Right. Meanwhile, you send the doubts. Any doubts are there? Okay. Right. Okay. So student, tell me. Already we 2-3 times I have told the basic formulas present in photoelectric effect, dual nature and radiation. And also I have said we have discussed questions from module also already. PYQ I sent to you. I hope you are practice that PYQ. So I ask you to any doubts are there in PYQ. I told you to send it. Still, before we discuss the doubts, somebody already sent the doubts. Before we start the doubts, because we have a till 12:30 we have a session. So first 1 hour we'll discuss dual nature. Next 1 hour we will discuss about atoms. Right? Tell me, till anybody have any topic you have in dual nature doubt is there, or you need some explanation, you ask me, so I'll try to explain that. If you do not have any that doubt, that is we start the questions only directly. Tell me anything you required from dual nature. Clear? Everything is clear in that dual nature, because already only one is related to photon, other is related to photoelectric effect equation. Third one, de Broglie wavelength. De Broglie wavelength. Correct? Right? Shall I start discussion of question? Somebody send to the doubts. So that doubts I am discussing, you see. Is it clear? Look here. In your module, they have sent that one question. Question number 13. Question number 13. Dual nature of matter brain module it is. Dual nature of radiation and matter waves. The chapter we are discussing right now. So in that the question is question number 13 in your module. See, the module may be 3. Module 3 it is 3 that module sorry. Question number 13. The question is given if the de Broglie wavelength for a proton and alpha particle are equal, then the ratio of their velocities will be de Broglie wavelength for alpha proton and alpha particle same they given. De Broglie wavelength is same means what? 13 the question. De Broglie wavelength of proton. 1 second, ink is not there proper. One second, you wait a minute. I'm filling the ink. So question number 13, I'm discussing lambda of proton is equal to lambda of alpha the given. De Broglie wavelength of lambda of alpha and proton is given. We know that H by mv, proton and proton, mass of proton and momentum of proton. Then H by what it is? Alpha, m of alpha and v of alpha. Ratio of their velocities they are asking. Proton to alpha ratio. So HH cancel out here. Vp will go there. So m alpha will come here. So Vp by V alpha will be equal to m alpha by mp. Inversely proportional ratio is there. Vp by V alpha is equal to m alpha by mp. We know alpha particle mass is a 4 times of proton mass. Alpha particle, helium nucleus, general helium. So helium means what? 4 times of mass of proton. So m alpha is equal to 4 times of proton mass by proton mass. So cancel out, which is going to be 4:1. So remember, m alpha is equal to 4 times of mass of proton and q alpha 2 times of charge of proton. This already I told many times. Clear? X-ray topics are not there in your syllabus. Leave that question I told. X-rays are not there in the syllabus. X-rays you can leave it. X-ray questions you can leave it. Then the question, next question number 17, you see, they've given the de Broglie wavelength of a particle moving with a velocity 2.25 10 to the power of 8 meter per second is equal to the wavelength of a photon. Okay. The ratio of kinetic energy of particle to the kinetic energy of photon is they want to find. Velocity of photon is given. So kinetic energy, the moving particle, this much of its wavelength is equal to the wavelength of photon. Same concept only. So question number 17 it is. Question number 17, de Broglie wavelength of particle moving with the 2.25 into 10 to the power of 8 meter per second is equal to the photon wavelength. Wavelength of photon is given. So they want to calculate here what is kinetic energy ratio, right? The ratio of kinetic energy of particle to the kinetic energy of photon they want to find. Clear? So we know lambda is equal to h by p, or which can be written as h by root over 2mk. Okay, or we can write here they given it as m we don't know, right? Particle mass we don't know. So here what we will convert, lambda is given is same only, but p we will convert into kinetic energy and velocity and kinetic energy, right? So look here. So h by mv, right? Or otherwise 2mk, k is the kinetic energy. So I'm first converts that kinetic energy for format 2m into 1 by 2 mv square. Kinetic energy of mv square, right? Kinetic energy is equal to half mv square here. So I'm writing m is equal to 2k by v square. We'll substitute there in place of m. Or wait, 1 second. It is not getting over. Question number 17, you see. Lambda is equal to h by p, right? So kinetic energy is equal to p square by 2m. P square by 2m. Correct? So we should eliminate here m. We should eliminate em here, because mass of particle we don't know. Kinetic energy particle ratio they want to calculate. So velocity is given. So directly we need to calculate in place of m, of mv square. In place of m, we have to replace with kinetic energy only. So m is equal to k, 2k by v square. Correct? Then lambda is equal to h by 2mk. Yes or no? H by 2m, you can write 2k by v square into k. Correct? So this can be written as 2 2s of 4. 4 into k square. So 4k square by v square. So lambda can be written as h by 4k square by v square root. So it cancel out h by 2k by v will come. Correct? So from here lambda can be written as hv by 2k. hv by 2k. So lambda directly proportional to v, inversely proportional to kinetic energy according to this. So directly we can cancel out here. So what I can write here? Lambda photon kinetic energy we can write here k is equal to hv by 2 lambda. Lambda is same given, ratio of kinetic energy of proton or a particle to kinetic energy of photon. Ratio will be v of particle by v of photon. V of photon is how much? 2.25. A particle 10 to the power of 8 by 3 into 10 to the power of 8. 8 cancel out. So it is 225 by 300. So 25 if you cancel out, 25 9s are 25 12s are. 3:4 is answer. 3:4. Lambda is given same only, right? Two 25. It's a 9 by 12. 3/4 only. This marker, it's not opening. Okay. Yeah. That I will check it once and say. But next question you see. Division and German experiment na, that I will explain. Wait, this question is completed. I will explain that. Next question number you see. I will explain the division and German experiment. You see. Question number 18. According to de Broglie, the de Broglie wavelength electron in orbit of hydrogen atom is 10 to the power of minus. How much it is not clearly visible. Atom is some in meter. I'm not getting exactly that one. Just can you send clear picture of that one? -9 or something. Okay, that much means the principal quantum number they are asking. So 18th question you see principal quantum number. So we know according to de Broglie second Bohr condition is explained, that is the circumference of the orbit 2 pi r will be equal to n lambda. Correct? Yes. So this is Rn in according to second radius of the orbit. According to Bohr, that is the electron in particular orbit radius will be Rn is equal to 0.53 first orbit 0.53 n square by z. N square by z. So z is 1 if you take hydrogen atom. Rn is equal to 0.53 into n square I can write. So now it become 2 pi Rn. So 0.53 n square, that is equal to n into lambda. N cancel out. Correct? So we can get now lambda is equal to 2 pi 0.53 angstrom. Or you can write lambda is equal to 2 pi, n is there here, n. Or n into 2 pi 0.53 into 10 power minus 10 meter. So I'm that exactly lambda value, how much they given, I'm not seeing exactly. So you can substitute the lambda here and 2 pi and 10 power minus 10, everything constant only. N principal quantum number you can able to calculate from here. Lambda exact value not visible exactly here, 10 to the power of minus 4 or minus 10 I'm not getting. So substitute here and n will get here automatically. Clear? Then question number 19 you see. Question number 19. The kinetic energy of electron and the proton is given. The kinetic energy of electron and the proton is 10 to the power of minus 32 joule or how much? 32 joule. Then the relation between their de Broglie wavelength they are asking. So same is given. Kinetic energy same is given. So kinetic energy same is given means lambda is equal to h by 2m k or E, whatever you can say. E is a kinetic energy or k also kinetic energy. So E same is given. So lambda is inversely proportional to root m according to this, because E is same means only m is variable. So m variable means proton and electron, right? What they given? Electron and proton. So we know proton mass is higher than electron mass. So proton mass is higher means lambda of proton will be less, and electron mass is very less. So electron wavelength will be very high. So we can write lambda of E is greater than lambda of electron, which were much more greater than lambda of proton, since Me lesser than MP. Proton mass is much more greater than that. So answer according to that you can select. Next after 19, which one? X-rays question you can leave it. X-ray question no need to do. I told earlier also X-ray question you leave it. Then after the 19th, any doubt in dual nature questions are there? Question number 51 is given, is it? Question number 51. I think this is already discussed in the class. Two identical photocathode receive light of frequency of F1 and F2 if the velocity of electrons of mass m coming out are respectively V1 and V2, then relation they want to calculate. Correct? So relation of that 51 question, you see, frequency is given F1, F2, wavelength is given, speeds are given V1, V2, maximum speed. That is photoelectric equation is what? Half m V max square is equal to HC or HF minus work function. Correct? So they've given it. They've given it what is frequency F1, F2 and where maximum velocities are coming out be V1, V2 they given. So can I write from here V1 relation? I want to try to get it. So here V is equal to, I can write here. So or other directly will write half m electron only, mass is same, electron mass is same in both the situation. Half m V1 square first case frequency F1 minus work function. Second case half m V2 square that is equal to HF2 minus pi. Work function same in both the situation. So what we'll do, subtract these two equations. Subtract means sign will change, right? So these two will be cancelled out. This minus this we have to do. This minus this if you do 1 by 2m if you take common. V1 square minus V2 square. Left hand side and right hand side this is cancelled out. Then H if taken out F1 minus F2. Then from here V1 square minus V2 square directly we can write 2 will come here 2H by M into F1 minus F2. Correct? So according to that option you can select. So V1 square minus V2 square is equal to 2H by M F1 minus F2. Option number B. B option is correct. Clear na? Next, after 51, what are the doubts? 55. 55 from dual nature only you see of your module. of dual nature of your module question only we are discussing. 55 they given it as the maximum velocity of an electron emitted by light of wavelength lambda incident on the surface of a metal work function is given pi. If is H is a Planck's constant, m is the mass of an electron. And what they want to find? Speed of light. Maximum wavelength, velocity of electron. Maximum velocity of an electron emitted by light of wavelength lambda incident on the surface. Maximum wave velocity only they want to calculate. Direct question only it is. So half m V max square is equal to HC by lambda, correct? Minus work function. Work function pi is given. So lambda the incident photon energy wavelength they given, work is the work function pi is given, maximum velocity this one. Direct equation V max square is equal to 2 into HC by lambda minus pi. divided by m. Correct? And square it is there, it will come root. So V max is equal to root over 2 by m into hc by lambda minus pi. Lambda minus pi. Or they've given that this lambda they've taken as LCM. So lambda, if you take lambda pi by m, lambda will come. So option C will come. Correct option. Because if you take 2 HC lambda LCM, you take lambda pi by lambda, m is there, m lambda. Correct? So this is whole power 1 by 2 they give an option. So C option is correct. So after that 58th question you see in the same module of same page. So 55 after 58. So 58 they given it as photoelectric emission is observed from the metallic surface for a frequency of nu1 and nu2 of the incident light rays. nu1 is greater than it. The maximum, if the maximum values of kinetic energy of the photoelectrons emitted in two cases is V1 is to K. Maximum values of kinetic energy photoelectron emitted 1 is to K they given. Okay. Then the threshold frequency of the metallic surface. Threshold frequency they are asking. Okay. Right. So first case nu1, nu2 they given and threshold wavelength. Let us say frequency we are applying kinetic energy maximum, right? So K1 is equal to first case I am taking. Or normally equation of photoelectric equation is what? Photoelectric equation is what? Maximum kinetic energy, that is K max, is equal to energy of incident photon minus work function. Correct? Or this can be written as first. This can be written as furtherly. This is h nu minus h nu naught. K max is equal to nu is the incident photon frequency. Nu naught is the threshold frequency. So they want to find this nu naught only, threshold frequency of that metal they want to calculate. K max. So first case kinetic energy K1 you take. Okay. Then it will be h nu1 minus h nu naught. Yes or no? Yes. Now second case they are given it as K2. Then h nu2 minus h nu naught only. Yes or no? Yes. So this is equation 1 and 2. But nu naught, that is threshold frequency we need to calculate from here. Okay, we can calculate. But before that, K1, K2 ratio they given. They have given it as K1 by K2 is 1 by K they given. 1 by K. Okay. So from here nu naught we need to find out, means first of all we need to calculate what is K1 or K2. Anything you can calculate. If you divide, will directly this will be cancelled out. But nu naught is required here. Okay. So 1 second, we'll divide this. What we'll get from that K1, K2 you can calculate. Or otherwise, I can write K1 by K2 will be 1 is to K they given, right? 1 is to K. So let us say K1 is X. K2 will be Kx. Yes or no? Yes. So if you want to calculate this, can I write K1 is X is equal to h nu minus h nu naught. Second Kx is equal to h nu 2 minus h nu naught. So if I multiply this equation with the K, this equation with the K, I am multiplying. K, K, K. So now we will do subtraction. So minus, 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 plus. So this will be cancelled out anyway. And here minus means KH nu. 0 is equal to KH. If you take common, nu 1 minus nu 2. No. KH nu 2, nu 1 minus H nu 2. Here plus is there, here minus is there. Minus KH nu naught plus H nu naught is there. Correct? Yes. So I can write now from here. I can take H nu naught common, I can take, and this will take this side. Or other one more step I will write. So H I will take common, K minus nu 1 minus nu 2. That is equal to, or minus H nu naught if I take common. Minus H nu naught I will take common, here K, here minus 1 will come. Correct? So this will go, this side become plus. Correct? So it become H nu naught, K minus 1, it become plus. Then H into K nu 1 minus nu 2. H cancel out here. The threshold frequency nu naught will be K nu 1 minus nu 2 by K minus 1. This is answer. Multiply the K with the first equation and divide. After that, if you subtract, you will get the answer. Writing the equation of photoelectric equation in both the cases, and then multiply with the first equation with the K, then we'll get everything. So C option is correct. C no. B option. B2 na. B option is correct. Is it clear? Student, is that all the questions are clear? Question number 58 is clear. Yes or no? Tell me. Boys and girls, is it clear? Those you asked, ask you to told this question, doubts are there. Is that is clear? Your doubt is clear, or still any doubt in this question number 58 or 55 previously? From boys section, they asked this doubt. Is it clear? So still any question from dual nature? Tell me. Right. Division and germer experiment. One of you are asked that, right? Division and germer experiment basically. Division and germer experiment, you see. See, there is electron gun is there. Okay. And here they applied some potential. From here, because potential, high potential, they will apply just high potential. So based on from here high potential, this filament will be very, very hot. It will come. Due to that, filament or hot filament, what will happen? It will emit the electron by using thermoionic emission. Field emission, thermoionic emission, photoelectric emission. Three types of electron emission will be present. One is field emission, which high electric field is supplied, high field is supplied. Because of that, electron will come out from the metal surface. That is field emission. When certain frequency of wavelength photon falling on metal surface, electron will come out, photoelectric effect. When thermal energy, sufficient thermal energy is supplied, then emission, electron will come out from metal. That is called thermoionic emission. So here filament is very become hot because of current is supplied by this high potential. Then from here electron is comes out, electron emitted. So from this electron is emitting, this electron is coming, and there is some target material like crystal type of material will keep here, and this will hit on this. It will hit on this, and it will scatter. So this angle is called scattering angle pi, and here whatever is scattered electron, scattering electron, so it will be captured by some detector will be present. Detector will be present. So which will be going to be detect the scattering electrons. Scattering electrons, right? So from this, so this is pi and this is glance angle we call theta. Glance angle theta, and relation from theta and pi we can write. So this is also theta this side. So 180 is equal to pi plus 2 theta. So this can be written as 2 theta is equal to 2 theta is equal to 180 minus pi, or theta is equal to 90 minus pi by 2. This is relation between glance angle and scattering angle. Now what experimental base, basically what is the Davison and Germer experimentally found means, we know de Broglie wavelength of charged particle, or de Broglie assumed that a matter can has waves, or a moving matter can emit a wavelength which equal to lambda is equal to h by p or h by mv. Whenever a particle in state of motion, it will emit a wavelength that is emit h by mv. Similarly, Davison and Germer experimentally proved that electron wavelength, they calculated experimentally electron wavelength they calculated, like electron wavelength 12.28 by root v, right? So electron wavelength mathematically by using a equation of de Broglie equation, according to him electron wavelength is 12.27 by root v. V is the accelerating potential applied to the electron. So that means whenever accelerating potential changes, electron wavelength changes. So experimentally this Davison and Germer experimentally found for different potential they applied here. Electron is emitting and electron is scattering here. For different this one, they measure intensity, the intensity of scattering or intensity of this electron scattered. So are measured, they have got a peak value here at particular voltage, 54 voltage. 54 voltage they got. And the flashlight, whatever the scattering light, flashlight, they emitted or detected the wavelength of that one. Okay, exactly 54 volt, whatever the wavelength they have measured experimentally by capturing the scattering electrons, or by this scattering wavelength they measured or detected experimentally, then 54 volt you supply in this equation. Whatever the value we are getting here, theoretical value, generally this is theoretical value we call, and experimentally at 54 volt apply, right? Then scattering wavelength, whatever is measured experimentally, it is matched exactly at 54. So that experimentally proved that theoretical value of wavelength, theoretical value of de Broglie wavelength, and experimental value measured by the Davison and Germer exactly coincided. So that indicates that electron has a wave nature. electron, how it is scattered, how it is diffract, how it is interfering. Sorry, normal wavelength, waves. Wave how it is scattered, wave how it is diffract, or wave how it is interference. Similar to the electron, also diffraction of electron will be present, and scattering of electron. Based on that, experimentally proved that electron also behaves like a wave, which has a wavelength experimentally matched with the theoretical value. Okay, this one. So remember, at 54 only the peak value or flashlight they observed, and this 54 what flashlight they observed the wavelength of flashlight. Same 54 theoretically substituted here, they got same value. So hence it is proved that electron has a wave nature. Clear? Right? Anything doubt from dual nature? Numerical question. Doubts you are there from your side is there? Any doubts? Boys? Boys, do you have any doubt in dual nature? Now, let us atoms, coming to the atoms. Coming to the atom, any concept doubt is there in the atom? Tell me. Boys and girls, tell me any concept doubt or any numerical doubts you have from atom chapter. Now look here. Look here. Atoms. From this, basically, like one Thomson experiment, J.J. Thomson experiment and silicon oil drop experiment is there. But what briefly I will say that silicon oil drop experiment and what he called J.J. Thomson experiment. Theoretically, that much not important, but the formulas which we'll use in that already we have used it somewhere in electromagnetic waves and before that in cyclotron also. But how, again, I'll say that J.J. Thomson first. J.J. Thomson experiment. What is J.J. Thomson experiment? It means actually this scientist found experimentally or calculated the ratio of charge to mass ratio. Specific charge of electron is found. Calculated specific charge of electron. That means he calculated specific charge of electron. Specific charge of electron. That is E by M ratio. Specific charge of electron, E by M ratio. Charge of electron by mass of electron. That ratio is calculated experimental. Then how we calculated means, for that we have used that an electric field and magnetic field. Electric field and magnetic field. maybe electric field in one direction, however which direction, some kind of direction. Okay, so electric field and magnetic field they applied, they use in that electric field E bar and magnetic field B bar are perpendicular to each other and also perpendicular to velocity of electron. Velocity of electron. So they have used that concept of velocity, so what is called velocity and electric field and magnetic field, all are perpendicular. Like cyclotron concept, velocity selector concept is there na? In Lorentz force. You studied in moving charge and magnetism. So that is a special case they have taken in the J.J. Thomson experiment. So what is that means? Electron velocity perpendicular to velocity, electric field perpendicular, magnetic field also perpendicular. So that special case in that the force on electron or F net on electron, F net, because magnetic field is there, electric field is there and electron is there means charge particle is there means and it is moving means definitely electrostatic force and magnetic force both will be present. Yes or no? Yes. So F net on electron is 0. They balance in such that F net on electron will be 0. That implies what? Force of electrostatic, force of magnetic will be equal. That is QE is equal to QEB sign because it is perpendicular only. Q cancel out. So V is equal to E by B ratio. So here they have used the concept of velocity of electron which is passing through electric and magnetic field without deflection. Electron passing through the electric and magnetic field, combined magnetic field and electric field, they are arranged in such a way that perpendicular to each other and electron is leaving this field without deflection. Without deflection means net force is 0. So V is equal to E by B. By using this E and magnetic field, they calculated velocity. And this concept, kinetic energy of electron, kinetic energy is equal to kinetic energy of electron. Basically, charge particle moving means work done is only kinetic energy. So that you can calculate it by Q into V, potential difference. Potential difference, QV, work done. But kinetic energy, what we can write? Of m of electron into velocity square. This is equal to electron charge is E, V is a potential. Correct? Then from here, they have calculated the E by M ratio as E by M is equal to E by M. Then what happens? This V will go down. That is V square, small v square by 2 into V. Right? So here V is E by B according to this, E by B. So E square by, finally we get 2B square V, E by M ratio, specific charge of electron. Here V is not a velocity, it is a potential. E is electric field and B is a magnetic field. So this is the basic formula involved in the J.J. Thomson experiment. If they ask, you can use this one. Already this type of question I said. Clear? So this is already we use in the velocity selector, and C is equal to E naught by B naught we use in electromagnetic wave. Correct? Then kinetic energy or work done is equal to Q into V, already we use. But the same concept we use the J.J. Thomson experiment to find E by M ratio of electron. Clear this one? J.J. Thomson? So these three questions based on this concept only, you can try now. Whatever you have sent, that you can try now. The same concept of this one. J. Thomson experiment, find calculated E by M ratio by using discharge tube experiment. Collision of atom with atoms. Clear? Now similarly, one more we'll discuss millicon oil drop. Millicon oil drop experiment you will see. Discharge tube experiment, the J. Thomson experiment is used for calculation of E by A ratio and using concept. And whenever collision with this, collision of when metal surface electron emitted, right, from the same photoelectric concept only. But cathode rays, beam of electron will emit in discharge tube. When high potential difference you apply and low pressure you apply. Discharge tube experiment, high potential difference and low pressure. Okay. So different, if you change the electric potential, different colors will emit the gases. Different flashlight will come there. It's a collision between the atoms and negative electrons and neutral atoms or molecules, we can say. Clear? Now, millicon oil drop experiment. Millicon oil drop experiment, you see. Once we see that also. So basically, millicon's oil drop experiment. What is this? Means he found or calculated, experimentally calculated charge of electron, that is 1.6 into 10 to the power of minus 19 coulomb. We are saying that is found experimentally by millicon oil drop experiment only. So charge of electron. Charge of electron. So how we found means is arranged a setup in that oil drops are falling. Oil drops are falling, and that is arranged between the two metallic plates. These two metallic plates are connected to a potential. Like this arrangement is given. Okay. So here two plates separated by d distance. Clear? And between the plates, they are arranged in such a way that oil drops are falling. From that external chamber will be present. From there, oil drops are falling. Drops are falling like this. Okay. These two are, this is A and this is B, are metal plates. And these two plates are going to be connected to a battery. Okay. Like this, higher, lower potential, V volt. So now, when it is connected to positive terminal, this plate become positive charge. And this is negative charge. So electric plate, field between them, this will be arranged in this direction, electric field, because higher potential to lower potential. Then a drop is falling. Drop is falling. So drop is falling means on the drop, what kind of forces can act? One is falling means gravity will act. Second thing, it is falling between the plates, and that has higher potential and lower potential. That means electrostatic force will be present. Second force. First gravity, second electrostatic. So if it is the medium, anything like fluid medium is there or air medium is there, so that means fluid, whenever drop is moving in a fluid or a particle moving in a fluid, a viscous force will act. Drag force or viscous force will come to try to oppose the motion of the drop. Third force is the drag force or viscous force. Fourth force will be buoyancy force. Like any particle or any object moving in a fluid or motion in a fluid, upthrust will act. Upthrust or buoyancy force will act due to fluid. Correct? So here in this experiment, that liquid drop will be liquid drop can move up or down or kept rest between the plates. Liquid drop can move up, can move down, or it can be at rest between the plates. So can move up, can move down, can be at rest means it depends upon the what are the forces are acting on the drop and what are the what are the forces are acting on the drop and in which direction large force is acting. Can move up means large force is acting upward direction. Can move down, large force is acting downward direction, or net force acting up or net force acting down, or rest means net force 0. Net force 0. Clear? So this drop can be a positive charge or it can be a negative charge. Experimentally calculate the charge of electron. So electron also here, the drop can be a positive charge or negative charge. Drop can be positive or negative charge also. Negative charge, positive or negative charge. But simple, what is the difference between a positive charge or negative charge? Means only the difference comes in electrostatic force. If drop is a positive charge, it will experience a force in the direction of electric field. In which direction electric field is there, that direction only force will be present. If it is positive. If it is a negative charge, drop is a negative charge, in which direction electric field is there, opposite to that force will be experienced. Opposite to that force will be experienced. So that means because of positive charge and negative charge, only the difference will come in electrostatic force. Electrostatic force. Then remaining drag force, which is always opposite motion of the object, viscous force, nothing but fluid friction. So it is moving up means drag force downward. It moving down means drag force upward. Then rest means all the forces will be balanced. So first I'll say forces acting on liquid drop. Acting on liquid drop. So what are the forces? One, without any doubt, mg, gravitational force. Correct? If it is positive charge, according to the diagram, positive charge, electric field is upward, so electric force also upward only. So consider positive charge, which is Fe, upward. Yes. Okay. Then buoyancy force, while it is falling down means buoyancy force act upward only, while it moving upward, fluid buoyancy force, B. Buoyancy, B stands for buoyancy or upthrust. Correct? Drag force depends upon the drag force. It may be a up or it may be a down. It may be up or it may be a downward direction. So I am taking, for example, it is moving up. It is moving up. Let us assume that. Moving up means drag force will act downward. FD. FD. Drag force FB. Buoyancy force and FV electrostatic, mg is gravitational force, right? It depends upon that, right? Suppose F net will be 0. If it is rest, F net is 0. For rest. Okay, for rest. So what I can say now, F net is 0 means all the forces and upward should be equal to downward force. That is Fe according to the diagram. Fe plus F buoyancy will be F drag force plus mg should be equal. Then only F net force will be 0. F net will be 0. The equation for calculation of electric charge by using that. So no need of that equation. Nobody will ask that equation. But thing is, why I am saying this one means the question of they will ask from based on this silicon oil drop experiment. So you need to clear with one. What is aim of the experiment? He calculated charge of electron. Charge of electron. First point clear. By using a setup of a drop is allowed to fall between the plates, metallic plates, and these metallic plates are connected to the battery. So nothing but indirectly battery connected means indirectly between the plates electric field is there. Electric field is there. Clear? Drop is falling means mg force will act, drag force will act, buoyancy will act, and electrostatic force will act. 4 forces. Clear? Then liquid drop can move up, down, and rest in the between the plates. And it can be a positive charge, it can be a negative charge. Clear? Na? Question how they will ask, look carefully. Question how will they ask? Suppose a drop is moving up. Or drop is at rest, positive charge drop or negative charge drop at rest is there. So which direction electric field should be act, or which what is the forces should be balanced, etc. They will ask, right? So let us be see, but this is clear. What are the forces are acting and what is the aim of the experiment? So in this one, because voltage is given, distance between the plate D is given. So electric field we can calculate. Electric field is what? V by D. Whenever sometimes they won't give electric field directly, so V by D we can calculate. V is the potential and D is the distance between the plates. Sometimes electric field directly they will give, or otherwise V by D we can do. Potential if they given, V by D we can do it. Clear? These points are clear. What are the forces are acting and what is the aim of the experiment is clear, student? Drag force means viscous force. Viscous force, na fluid friction. Fluid friction, that is drag force we call. Whenever a particle is falling down in the air, so air will apply force on the ball or body upward direction. That is drag force we call. Try to oppose the motion. Clear? Now I will just conceptual question I will ask based on this concept. You see, not much is there in the syllabus, but still there may chances, little bit chances are there. A drop will rest means what is the direction of electric field, what is the direction of force. They will ask maybe simple steps. Let me discuss that. Now look here. Look here. Here there are the two plates we have. Plates. Between the plates, one drop is there. One drop which is at rest. So mass of drop is 0.2 into 10 to the power minus 4 kg. Minus 4 kg. Okay. Mass of drop is 0.2 10 to the power of minus 4 kg. And neglect buoyancy force and drag force. Buoyancy force and drag force. So drop is positive charge or not giving positive charge. Okay, let us take. Look, this is drop. An electron which is moving upward direction. Electron moving up, drop is there, rest only. And drop is at rest. Drop is there at rest. And the drop mass is given, drop is at rest position is there, and one hint is given, electron is moving upward they given. And this is a plate A, this is a plate B they given. What is the question mean? So, what is charge, nature of charge? What is the nature of charge of a drop and magnitude of electric field? We need to calculate. Magnitude of electric field we need to calculate. Okay, if charge of drop is given 1.6 into 10 to the power of minus 19 coulomb. Okay, so tell me, question I'm trying to say one more time. Between the plates, one drop is there, which is at rest position. The drop mass is this much, and drop is at rest. So, what is the nature of charge of a drop? Nature means plus or minus. And magnitude of electric field we need to calculate. The charge is given 1.6 into 10 to the power of minus 19. Then which plate is positive, which plate is negative? For that, they have given a hint is electron is moving up in the diagram they given. Electron is moving up. So, first of all, drop is at rest means all the forces are acting on it should be same. That is, net force should be balanced. Net force should be balanced, correct? Then only drop is at rest. Now on this drop, what are the forces are acting here? One is mg, without any doubt mg is acting because m is given here. M is acting. And it is at rest means, so some other force should be balanced. I told here neglect the drag force and buoyancy, neglect it. So only mg is there definitely. So one more force should be balanced means what? Fe should act. Fe should act, right? Yes or no? Fe should act. So that means first of all, magnetic force or electrostatic force is equal to mg. Then Fe is QE is equal to mg. Then E can be written as mg by q. So directly E, magnitude of electric field, you can calculate it by using this as so E can be written as m 0.2 into 10 to the power of minus 4 kg. G is 10 you take, and Q they given 1.6 into 10 to the power of minus 19. Minus 4 minus 19 cancel. Minus 15 will come. So this is 2 by 16 into 10 to the power of 15 it will come. Correct? So 2 ones are 2 eights are nearly 1 by 8 into 10 to the power of 15. Correct? Yes or no? So this is volt per meter. Electric field strength we got. But one more thing they are asking, nature of charge. whether it is positive charge or negative charge. Further, whether it is positive charge or negative charge, you want to know it. According to this is drop is at rest mean gravitational force mg should be balanced by electrostatic force. But mg acting downward, electrostatic force should be upward to keep it rest. Should be upward. So electrostatic force upward means, so electric field should be upward. Electric field should be upward. Correct? Electric field should be upward. Clear na? So electric field should be upward means, so in which direction force will be present, that direction only electrostatic force. So electrostatic force upward and electric field is upward should be present. So here electron moving upward means this is positive charge. Correct? So electron moving upward. So negative charge is moving up. So negative charge is attracted towards positive charge. So this plate should be positive. According to that, automatically this plate will be negative. Correct? So electrostatic force is upward should come. According to the diagram, electric field is downward is there. But electrostatic force upward required. So for that, this drop should be a negative charge. Then only electrostatic force opposite to electric field will act. Because according to this hint given, electron moving up, that means this plate should be positive because electron attracted towards positive. Then this plate is positive means this is negative. Then downward is electric field. Then on the drop, electrostatic force should be upward to keep it at rest. So according to that, electric field is downward is there. Electrostatic force upward should get means. So opposite to the electric field means negative charge. It should be a negative charge. So charge is negative. Once 2 seconds you see the board, whatever doubt is there in the question you ask me. Simple concept only. Sorry. Any doubts are there? Tell me in this question. I will explain once again. You see, before I did not mention the plus minus here. They have given a hint electron moving up between the plates. But in that between the plate, one drop is at rest. And the mass of drop is given 0.2 into 10 to the power minus 4 kg. Drop is at rest, they mention. They want to calculate the magnitude, nature of charge on the drop and magnitude of electric field. So charge of drop is given. So it is at rest mean basic will be forces should be balanced. And I told that is drag force and the buoyancy force neglected. So neglected means in vacuum, let us say you can vacuum, we can consider. So no buoyancy, no drag. So mg downward, upward Fe. Because force must be balanced means mg downward, automatically mg is downward only, no other case. So Fe upward, correct? So Fe upward means, so Fe is equal to mg, that is Q is equal to mg. So E we can calculate it from here. We got E value here. So how I said it is nature is negative means electron is moving up between the capacitor, between the plates. Electron moving up means what? Electron has negative charge and it will attract towards the positive, repel with the negative. So it is moved towards the positive plate. So this should be higher potential or positive plate. Then this is positive means automatically this is negative. Yes. So electric field to positive to negative will be present. Yes. So electric field is downward, but we require electrostatic force upward. So that is possible only by charge should be negative. Then only opposite to electric field will be present. Charge should be negative. Is it clear? Tell me student, is it clear? Any doubt? Right. So now in atom chapter, remaining concept already we know. Remaining concept what it is? Rutherford experiment, alpha particle Rutherford experiment. Alpha particle Rutherford experiment is what? One is question related to the number of alpha particles scattered at what angle? N is inversely proportional to sine to the power 4 theta by 2. Theta is the angle of scattering. Correct? And one more, closest approach distance. For that, yesterday only I said, for closest approach distance, what we can do? Potential energy of system is equal to kinetic energy of alpha particle we have to do. For that, after getting closest approach distance, impact parameter we can calculate it. That is perpendicular distance between initial velocity vector of alpha particle to the center of the nucleus. So that you can calculate it by B is equal to impact parameter d by 2 cot theta by 2. Right? So that is for alpha particle scattering experiment. Remaining Bohr model. Bohr model is what? Angular momentum nh by 2 pi conserve. MVR is equal to nh by 2 pi. Electron revolves around the nucleus in stationary orbit called, in which orbit electron momentum, angular momentum is conserved or quantized. So that orbit we call it as stationary orbit. So if electron move in that orbit, it won't radiate any energy. But whenever it is jump from higher to lower energy level, it will radiate the energy in the form of photon. Correct? So that will emit in the form of a photon. Then whenever it is emitted energy in the form of a photon, that energy you can calculate it by energy gap. Whatever the energy gap is there or difference of energy level is there between higher to lower energy, that will be equal to h nu is the photon energy, right? So that is third postulate of Bohr, right? The third postulate, based on the three postulate, then we have calculated different terms like terms like radius of nth orbit, velocity of electron in nth orbit, right? Acceleration of the electron in nth orbit, and different terms we calculated. What is magnetic moment, current produced by electron, right? Energy of electron in nth state, different terms we calculated. One in that important one is based on how to calculate energy in different orbits. Second one is wave number or wavelength of spectral lines, how to calculate, and maximum and minimum wavelength of particular series, how to calculate, right? And the last one is how many number of spectral lines emit when it is jump electron from higher to lower. That is a basic concept we have in atom chapter. Correct? So still anybody have doubt in that, or any question doubt is there, you send it to me. Yeah, that will mention in the question. Electron direction is mentioned in the question. Clear? Any doubt from this concept of atom? Look here. I'll write one question, you do and tell me. These are the 5 energy levels we have, right? Then electron is jumping from fifth energy level to second energy level is jumping. Okay. So we know how to calculate energy of this photon jump from here to here. First you calculate what is energy of photon emitted during this transition. Okay. Second, wavelength you calculate, lambda of photon, right? Third one is number of emission line possibles. Emission lines possible, number of emission line. Then it is make a transition from n equal to 5 to n equal to 2. What is energy of photon emitted, wavelength of photon, and number of emission lines emitted during this transition we need to calculate. Do yourself. Simple question only. Electron make transition from n equal to 5 to n equal to 2. So in that, what is energy of photon emitted during this? Lambda of photon and number of emission lines, possible emission lines. Look here. What is energy of photon? When energy released, when electron jump from higher energy to lower energy level is what? Delta E, that is E2 minus E1. That is equal to 13.6 1 by n1 square minus 1 by 2 n2 square. Any electron volt only, right? In electron volt. Take it, it is H atom only. For H atom. For H atom. For H atom. So energy of nth state electron is 13.6 Z square by n square. Z is 1 only. So electron transition makes from n equal to 5 to n equal to 2. So we can write here n1 is what? 2, n2 is 5. So delta E can be written as 13.6 into 1 by n1 4, that is 2 square, minus n2 5 square. Correct? 13.6 4 and 25 is there. 1 by 4 minus 1 by 25. So from this energy of photon we can calculate it as 13.6. LCM is how much here? 4 into 2500. So which is 25 minus 4. So which is nearly 13.6 into 21 by 100 electron volt. This is the energy of photon emitted in electron volt. 13.6 into 21 by 100. The second question you see lambda of photon, that simplify you can do it. Lambda of photon, wavelength of photon they want to calculate. So directly once you know the energy of photon, you can calculate the wavelength of photon by using directly lambda is equal to 12400 by energy in electron volt. You can substitute directly. So we have calculated energy of photon in electron volt only. So lambda you can calculate it by 12400 by 13.6 into 21 by 100. So I can write this is 13.6 into 21 by 100 means it will go to numerator. So answer it will come in angstrom. When you take E is in electron volt, lambda it will come angstroms. So that is come in angstrom only. The last one, number of emission lines. How many emission lines it will come? How many emission lines will come? Tell me. Electron make transition from n equal to 5 to n equal to 2 in hydrogen atom. Number of emission lines possible 1, 2, 5 or more than that. Tell me. 10 lines. So that you need to calculate because it not be a 1 because and it's not a 5 also. How it is possibility means electron can jump directly from n equal to 5 to 2 or it can come electron from here to here and from there to here and here. Possibility, probability I am asking here, right? And again it can directly jump from this, right? So how many possibilities there means like this electron can directly because of when electron excited to higher energy level, so it try to attain its stability. So stability is there at lower energy level or most stable at ground state only. So immediately with a fraction of second which is excited electron immediate make transition to the lower energy level, try to attain the stability. So while it is making a transition coming into lower energy level, that can be possibility directly come to 2. It come to 4 and 4 to 3 or 3 to 2 or 4 to 5 to 3 also or 4 to 3 also. Like the different combination will be present. So already I told one formula, right, to calculate what is number of emission lines possible for this transition. What is that? N2 minus N1 plus 1 into N2 minus N1 by 2, right? So N2, N1 here there, N1 is 2, N2 is 5, you substitute there, 5 minus 2 plus 1 into N2 minus N1, 5 minus 2 by 2. So 5 minus 2 it is 3 plus 1, 4, 3, 12 by 2, 6. Number of possible will be 6. Somebody given 10 is that, but wrong it is. We have drawn in the diagram also. Directly n equal 5 to 2 it will come. N to 5 to 4, 4 to 3, 3 to 2 or next combination 5 to 4 and 4 to 2 also. So totally how many? 1, 2, 3, 4, 5, 6. Right? So 6. Even if you calculate it from formula also 6 will come. Clear? The 10 will come when transition makes from n equal to 5 to n equal to 1 ground state. If it is ground state it will come. Maybe your applied formula n into n minus 1 by 2. But this is applicable only if it make transition to ground state. So it's not in ground state, right? First excited state it is there. So this is not valid. Substitute what is coming here, n is 5, higher energy level. So 5 into 4, so 20 by 2, the 10. So you apply this one, but it is wrong. It is applicable only when electron make transition from higher energy level to ground state it will come. Then only you can apply n into n minus 1 by 2, NC2 basically that is, or n into n minus 1 by 2 number of possible lines will come. But apart from if ground state is not given, so any other state is given, this formula we need to apply n2 minus n1 plus 1 into n2 minus n1 by 2. N2 is higher energy state and n1 from into the electron coming into which lower energy state, that is. So according to the diagram, the 6 is the number of emission lines. Clear? Yes, somebody calculated 6. It's correct only. So like this, you can calculate the wavelength or emission. What is the energy of photon also you can calculate during the transition of that, right? So one more question I will ask based on this concept only. Let us see. The question is given, binding energy of helium is 24.6 electron volt. 24.6 electron volt is given, right? So we need to calculate, find the energy or total energy, we can write. Total energy need to remove both the electrons, from ground state. Binding energy of helium is given 24.6 electron volt. Helium atom it is. Find the total energy need to remove both the electron from ground state of helium atom. Right? Calculate. (24.6 electron volt binding energy. Binding energy is what? Energy required to remove an electron. So how many electrons present in helium? See, look here. In helium, 2 electrons are there, right? 2 electrons are there. So directly for helium atom of 2 electrons, Bohr model is not directly applicable. Somebody may be thinking 24.6 electron volt for binding energy of helium atom. Then 2 electrons are there, multiply with the 2 will get the answer. No. So helium directly two electrons are there. So direct for helium atom, the Bohr model is not applicable. So according to Bohr model, the ground state of energy for any hydrogen-like atom, the ground state energy is what? Minus 13.6 Z square by N square, or N is 1 only ground state. Z square, right? So for helium, the ground state will be minus 13.6, Z square will be Z. Atomic number of helium is 2. So which is minus 13.6 into 4. Correct? So nearly it is how much? 54.4 minus 54.4 electron volt. This is the energy in the ground state of helium. But when it is applicable, this is ground state of energy means helium 2 electrons are there. Only when single electrons are there, hydrogen like atoms are there, for this only Bohr model will be applicable. But in directly they have given binding energy of helium 24.6 electron volt is given. Right? So in helium basically 2 are there. In that one electron to remove one electron, 24.6 electron volt is required. Then after removing of one electron, it is converted as He plus only. He plus. That means single electron of helium it is converted. Now we can apply the Bohr model. According to Bohr model, energy required or ground state electron you remove in helium atom in 54.4 electron volt is required. Right? So total energy is what? Initially, before we apply Bohr model directly, one electron you want to remove, 24.6 electron volt is required. But after removing of that electron, it's converted as single electron of helium atom or hydrogen like atom. So directly Bohr model we can apply for this. So total 2 electron you want to remove, 1 electron for 24.6, second electron 54.4 according to Bohr model. So total energy will be how much? Will be 24.6 for the first electron to remove. After that, by using the ground state of helium, 54.4. So totally how much it is? 79 electron volt is required. To remove both of electron from helium, the energy required will be 79 electron volt. Clear? See, once again I will explain here. See, in the question they have given binding energy of helium, that is electron, how much energy required to remove an electron. So that is 24.6 electron volt. Find the total energy need to remove both the electrons in the ground state. Right? So here 24.6 electron volt to remove one electron. The remaining electron you want to remove, 54.4 electron is required according to Bohr model or energy in the ground state. So minus 54 point, nothing but energy supplied will be 54.4 electron volt. The total energy will be 24.6 and 54.4. 79 total. Clear? I said that J.J. Thomson experiment is used to calculate specific charge of electron. Based on that concept, it will come. Use that concept and do that questions. Is it clear this one? Clear? Any other doubts from this atom chapter? So for tomorrow exam, so already you have practiced the module, right? Still any doubts are there, you can send it to me. And meanwhile, you read line by line the module, whatever you got module, the line by line you read from the module and your notes also. Some theoretical question you can answer based on that. That whatever you have sent the question which is electric discharge through gases at low pressure at high potential difference. Yes. The third question and second question is same only, negative charges and collision with the negative charges and neutral atoms. Second and third same only. And the fourth question which is E by M of proton and E by M of electron. Which one is normal greater? Normal E by M of electron and E by M of proton. E is same only, charge is same only, mass of electron much smaller than the mass of proton. So denominator is heavy. So this ratio, specific charge of proton will be less as compared to specific charge of electron. Specific charge of electron will be more than specific charge of proton because mass of electron is much smaller than the mass of proton. The charge is remains same, specific charge is inversely proportional to M. M is small, specific charge is high. M is greater, specific charge is less. For the proton and electron, that combination. Clear? Right. So we will end this session. So tomorrow you write exam that dual nature and atom chapter. Any doubts are there? Meanwhile, you can send it to me. We will answer it through WhatsApp group. Clear?